Hello, Matrix, and welcome again. Today we are doing cubic functions. Now, we finished off with functions before, and we did a parabola, which is basically x squared. Now, a cubic function is x cubed, but then we went on to calculus. The reason we didn't do cubic functions straight after parabolas is because you need to know calculus in order to figure out the turning points for a cubic function. So let's look at how we would do that. But first, what I want to do is look at a cubic function and what it looks like. So with a parabola, we always had two roots. We had two x-intercepts. Of course, sometimes you would have if it was moved up, you'd have no intercepts, but generally you would have two intercepts. Now with a cubic function, we have three, right? Straight line, we had one. Parabola, x squared, we had two. And so basically, whatever number you see, the biggest number of the exponent of x is how many roots you generally have. So now let's look at if it's a plus or minus in front of the x cubed, because that is going to tell you if it looks like this, the first one, or like this, the second one. Okay, so what I want to do is say that we had a negative x cubed. Well, let's start with positive, actually. So say we had a positive x cubed. Well, let's take the extreme example where we had like 1,000,000. So obviously the x cubed, that's going to be the biggest number, because 1,000,000 times 1,000,000 times 1,000,000 is going to far outweigh all of the numbers, whatever they are, on the x squared and the x. So let's take 1,000,000 cubed, and that's going to be just a huge, huge number. So plus 1,000,000 cubed, as we go towards this way, which is, say, as x goes towards 1,000,000, or in other words, into infinity, we get a very large number. Okay, and if x was, say, negative 1,000,000, well, negative times negative times negative becomes negative. And so as it goes towards negative infinity, it actually goes downwards. And so this is what it looks like when it's a plus x squared. Now, when it's a negative, suddenly you're going to have that, if we had a negative in front of the x squared, well, when we put a negative, a very big number, as it goes towards infinity, okay, we're going to get negative, a very large number. So it's going to go that way, okay? And so this would be the graph, the cubic function, if we had a negative. So when you're trying to figure out, does the snake go like this or the other way around, just think of the extreme and sort of give x a number, say 1,000,000, and then say, well, what would happen if I made it 1,000,000? Well, it would just go very big. It would go that way. And if it was negative 1,000,000, it would go downwards. Okay, so that's what the plus or minus tells us. So I'll just put a yellow there. So the yellow one, if it had been minus x cubed, goes this way. Okay, so we're going to draw the function of this one, which was positive. So we know that it's going to look like the green. It's going to look like this. Okay. Now bear in mind, sometimes it could look like this, but we'll get to that. Okay, so with sketching these functions, the first thing we always do is find our x and our y-intercepts. Well, the y-intercept is pretty easy because we just make y equals 0. X equals to 0. And so 0 cubed, 0, 0, we're just left with a -4. So we know that the y-intercept is just going to be -4. Okay, so we can actually put that in the graph there, -4. So that's our first thing. Now, our x-intercepts, we make y equals 0. So 0 equals x cubed plus x squared minus 4x minus 4. Okay, now what I want to do is I want to find out one of the intercepts because it's not like I can factorize. So what I can do is I can try, so what I would do is instead of saying 0 equals, I would try and figure out, well, which one of these is going to give me a 0? And so I would say, first of all, here, if this is f of x, so this is the function, I'm going to, instead of saying y equals, I'm going to say f of x. And you'll test. So what you would normally do is you test, and you test 1 first to see if that gives you 0. And of course, sorry, 1. You can test 1. Cubed plus 1 squared minus 4 times 1 minus 4. And we end up getting not a 0 at all. We get minus 6. So it doesn't work. Now, for those of you with a silver calculator, you don't need to test each one, because what you can do is you can figure them out, and then you can sort of pretend that you figured it out by yourself, even though you didn't. So let me just show you for those with a silver calculator. Now, for those of you who didn't have a silver calculator, you could try with minus 1, and you can see that you would get an answer. Well, this minus 4 times minus 1 would give you plus 4, and plus 4 minus 4 gives you 0, and then this would be your minus 1 and your 1. So it would work with minus 1. But let's say that we are going to, we have our silver calculators, which I recommend getting if you want to save a little bit of time. And so you would then just put it in your calculator. So you would say mode, and you use the equation mode 5, and it's a cubic function, so it's 4. And then I put my a, which is the number in front of the x squared, so that's 1 equals. Then I would put 1 again, because that's b, and I would put my negative 4 in, and again my d would be negative 4. And my first answer is 2, negative 1, and negative 2. Okay, so I remember my answers were 2, negative 1, and negative 2. So obviously you wouldn't want to use, so you would just sort of mark them, take them down here, negative 1, negative 2. And I think the other one was 2, but it doesn't matter, we're going to work it out ourselves. So what I would do is I would say f of negative 1 equals, and because I've already put it in my calculator, I know that it works as one of the zeros. I wouldn't actually bother with testing it, because I've done it in my head and I get 0. So I would say, therefore, x plus 1 is a factor. Okay. Now, the next thing I do is I'm going to find my other factor. So this I do by inspection. So what I do is I write out my x cubed plus x squared minus 4x minus 4. I say, right, well, x plus 1 is a factor. Now, what times x squared will give me x cubed? Because that is going to be my second bracket, which is going to be an x squared plus something x plus something. Well, x times x squared will be the x cubed, and then my final at the end of the bracket will be the number that gives me the minus 4. Well, 1 times what gives me minus 4? That'll be minus 4. Then what I do is I look at my x squared, and I currently have plus x squared. So that will, I won't need, so x squared, basically, I've already got x squared, so I know my middle number is actually 0. And so this last bracket is actually just x squared minus 4x. I don't need to get anything else to balance out my x squareds. And of course, if I times minus 4 times x, I get minus 4x. So I then factorize that further, and I get x minus 2, and I get x plus 2, and I get those same answers, which I used with my silver calculator. So therefore, my intercepts are x equals 1, minus 1, minus 2, and 2. So I can put those over here. So we would have minus 1 would be 1, minus 2 would be another, and 2 would be my third one. Okay, now the next thing is my turning points. And so here, remember that when I have a turning point, that is where my slope is 0. And from calculus, I know that in order to get my slope, I need to figure out what my turning points are. In order to get my slope, I need to find the derivative. So in order to find the derivative, I can just say f dash of x. And so this is going to be now in green. So f dash of x equals, and I've got 3x squared plus 2x minus 4. Okay, and now I'm going to figure out my turning points by making this equal to 0. So what I could do is I can just, to make sure that it works and I don't spend too long trying to figure this out, what I'm going to do is use my silver calculator. Now, what I could also do is the quadratic formula. If you're not sure how to factorize this, I do have a video on how to do the factorization of a trinomial, the four different methods. I'll put that in the link on the video now, so check that out if you're not sure how we do this. But let's have a look. So we're going to clear this, and we're going to say mode, equation mode again, but now we're going to use the x squared, so 3, and we're going to say 3 equals 2 equals, and minus 4 equals. And here we have our x-intercept. So the first one is going to be this, right? So what I do is I'm going to say x equals, because now I know that I would have needed a quadratic formula, I would say negative b, so negative 2 plus or minus the square root of 2 squared minus 4, a was 3 and c was minus 4, all over 2 times 3. And I know my answers are going to be 0,87. We're going to do it to 2 decimal places, or that's the second one, minus 1,54. Okay, so that would be the one turning point is between these two. And the other one is between, so the one is over here somewhere, but obviously it's going to be either up or down. And then the other one will be 0,87, so about there. Okay, now I know that I had a plus, so it's going to look like this. And there, so I'm probably looking at something like this, okay? So that green one, because it was a positive and I had my turning points there. Now, all I need to do is simply plug in my negative 1,54 into this original equation. Okay, so I'm going to do that now. Okay, so what I do is I put it in a calculator like that. and I put -1,54 in there, into this, substitute in. I'll obviously write it out, but I don't have enough space. And that is going to give me 0,88. So I know that this value here is 0,88. So my one turning point is 0,88, 1,54, and the y value is 0,88. So this point here, this turning point was -1,54. Okay, let me just do that in a smaller pen. 0,88. So if they ask you to label all these turning points, and now what I do is I put in the next one, the 0,87. Okay, so I put that into this equation. I get 0,87 cubed plus 0,87 squared minus 4, 0,87 minus 4 is equals, and I get minus 6,06, which makes sense because that is going to be over here. Okay, so that would be my second one. So I would say 0.87 and -6.06. Okay, so that would be my other turning point. Okay, so what I did, I got the derivative. I made the derivative equal to 0 because that would tell me the slope was 0, and that makes sense because it's a turning point where there is no slope. And then I sub it back into the original equation to get the y value. And then the final thing is the point of inflection, which is simply when I get the derivative of the derivative and equal that to 0. So in other words, I have the derivative here, which I figured out in green. Now I get the derivative of that. So that f, so this is 0.4 in yellow, f double dash of x is equal to 2 times 3 is 6x plus 2, and I let that equal to 0 in order to find my point of inflection. And I'm going to tell you what that is now. So we make that equal to 0 like we did with the normal derivative, 6x plus 2. And then we take the 6x to the other side, we'll take 2 to the other side, we get 6x equals -2, x equals -1/3. And so that would be about here. And I could then sub that into the original equation in order to get my y value. So let's do that quickly. So I'm going to put here so we're going to make it negative, or just make it 0.33. It'll be close enough. But you can use the fraction button as well. Negative 0.33. Negative 0.33 equals, and it should be something below 0, and it is. It's -2,67. So I'm going to put the point of inflection in as well. So this point of inflection, obviously you'd have more space than I do here, would be -0.33 and -2.61. Okay, and let me just tell you what the point of inflection is. So that is when the graph changes from concave down to concave up. So let me just explain that with the above thing, and I'll use, what have I not used? Let me use orange for concave down. Okay, so a concave down graph looks like that, right? The parabola. So that's the sad face parabola. So that would look like that. Now, if I was to extend it, we can see that I get a parabola. And on the other side, we have a concave up. So that would look like, and what other color have we used? Red. And so that would be the concave up. So every single one of these, so here's the concave up on the other one, would look like this. So all of these cubic graphs, they change at some point from being concave up to concave down. And the way they change from concave up to concave down is called the point of inflection over here. And so here, at this point, it changes from the concave down to the concave up. Okay, so if they asked you, where is the graph concave down? That is where it's a sad face, and it's where the graph is, well, it stops being concave down at minus 0.33. So it's concave up, so it's concave down. It's concave down, where x is going to be less than negative 0.33. And the red bit was the concave up, and it's concave up where x is greater than negative 0.33. So that is what the point of inflection means. It means where it goes from concave up to concave, well, in this case, because it's a positive x squared, it went from concave down to concave up. Okay, so that is what the point of inflection is. So there's a couple of new things there. Where in parabolas, to get the turning point, you just use the negative b over 2a equation. It was much more simple. Here, what we're doing is, because there's 2, we can't just say negative b over 2a, so we have to let the derivative equal 0. And then, where it's equal to 0, those are our 2 turning points, which we then sub back into the original equation to find our 2 turning points. And then the other thing we learned is the point of inflection, which is where the graph changes from concave down to concave up, or concave up to concave down. And that is where the second derivative, in other words, the derivative of the derivative, is equal to 0. Okay, so hopefully that helped. We'll do another example with cubic functions, but as you can see, it's the same steps. At 1, you find the y-intercept, as usual, quite simple. 2, find the x-intercepts. Now, you can do that now by just simply making y equals 0. And then if you've got your silver calculator, it makes it much easier, but we do it by trial and error and then by inspection. Then the third thing is we find our turning points, which is where we find the derivative and make it equal to 0. And then the final thing is sometimes they might want the point of inflection. So hopefully that helped. That's how to draw a cubic graph. We will do it again. If you want to watch the video a second time, if it didn't make sense the first time, you can even send me an email if you want, or a message at the bottom if you've got any queries on that. If this helped you, please find the like, subscribe button down below, click it, and share with all your friends and all that good stuff. You'll also get notifications on when I post the next videos to help you with your Matric Maths. And that's it. So next time we're going to do another cubic function example, which is more of an exam type question. And then we'll go on to optimization and follow that on with some financial math. So have a great day, and we will see you soon.